Okay, we are now ready to apply the properties of equality to start solving some equations on our own. In this lesson, I broke the equations into certain levels. Level 1 are equations that are ready to be solved right away because each expression is already completely simplified. So, for example, the expression on the left-hand side, there's no like terms to combine, and there's no parentheses, which would imply distribution, and the same thing for the other expression. So I'm ready to solve this. Now the easiest equation to solve is when you have x equals a number, right? Because whatever x is going to be that number, because if you replace the number with x, you would get number equals number. So the strategy is to work all the way down until you get x equals a number. So looking at this first equation, I notice that there's variables on both sides. So I'm going to apply a property of equality so that afterwards my new equation would only have variables on one side. So there's really two options I can do. I can say, all right, let's add 3x to both sides. And if I simplify each expression, the negative 3x and the positive 3x will make 0. So if you look to our notes up at the top, it says when you add or subtract numbers or variable terms, you're trying to make zeros. And that's what I did there by adding the 3x. So this expression would just become 29 equals 8x. That's from 5x plus 3x plus 5. Okay, now if you can solve this new equation by inspection, by looking at it, you can stop and write down x equals whatever you believe the answer to be. But if you're not quite there yet, well, there's other properties you can use. So remember, we're trying to get to x equals a number. Well, here's my term with x in it. It'd be nice if I could get that plus 5 to go away, and I can do that by using the subtraction property of equality, which would say to subtract 5. Right? What did I do by subtracting 5? I made a 0. And my new equation that I get will be 8x equals 24. Or the way it's written, 24 equals 8x. It's the same thing. And then from here, I can solve this by inspection, right? This is a pretty simple one-step equation to solve. 8 times a number equals 24. So I can say that x has to equal 3. Right, so x equals 3 works for this equation. It would work for this equation. And it would work for the one that I was trying to solve. Why? Because I only used properties of equality, and that guarantees that my answer is kept the same from equation to equation to equation. Okay, let's look at B. So this one is troublesome because not only do I have variables on both sides, but I have fractions mixed in as well. So when I see fractions, what I like to try to do is I try to clear the fractions. And the way we can clear fractions is by using the multiplication property of equality. So if I want to clear fractions here, I'm going to have to multiply by a number such that the denominator of each of the fractions will go into that number a whole amount of times. So for B, and you'll see after I do the work, I'm going to multiply this equation by 9 But remember, when I multiply, every term has to get multiplied by that amount. So the left-hand side expression has 2 terms, and the right-hand side expression also has 2 terms. Okay, so what's this going to become? 9 times 2 is 18. This is 9 times x over 9. Well, the 9 is in the numerator, and it's going to truly cancel out with the 9 in the denominator, and that's going to leave me with just 1x. For the other side, 9 times x over 3. Well, that's going to be, 9 in the numerator and a 3 in the denominator. Well, 3 goes into 9 3 times, and I would still have the x. So it would be 3x. And then 9 times, you can think of that as a negative 3, and that's going to be negative 27. All right, so the nice thing about that is now I have an equation without fractions. And the next thing I'm going to do is I'm going to try to get the variables to be just on one side. So I really have 2 options. I can either subtract 1x from both sides, or I can subtract 3x from both sides. But one choice is going to be better. As you'll see, if I subtract 1x on both sides, the nice thing about that is my variable term is going to stay positive. Okay, so I'm at this new equation, 18 equals 2x minus 27. I can't quite solve that by inspection yet, so I'm going to do the addition property of equality, and I'm going to add 27 to both sides. That's going to give me 45 equals 2x. And I see that 2 doesn't go into 45 evenly, so my answer is going to be a decimal. I'm going to use the division property of equality, and that tells me that x has to be 45 over 2. And as a decimal, I can write that as 22.5. Okay, so these are level 1 equations, and again, the reason why they're level 1 is because you can start solving them right away. You can go right into the properties of equality.